Okay, so we are going to be doing 9-3 today, and thanks to the weather, you're all at home, and I'm at home, so I'm going to make the recording, do the notes just like I would if you were sitting in class, and so I would like for you to take notes in your 3-ring binder just as if we were in class, because they will be included in the note check when we get back to school, and then try your assignment. And most of you should have a paper assignment that I gave you this week at school. If you don't, you can always hit Cami. There's not a whole lot of work to these, so Cami wouldn't be too difficult to do the work if you don't have a paper copy. So, and of course, as always, if you have any questions at all, you can email me. And because of this kind of unique e-learning day, I'm also going to have a Google meeting open from about 9, which as soon as I finish this video, from about 9 o'clock to 3 o'clock. And it'll just be a live video open all day long. There's a link on Canvas already, and you can just pop on, pop off if you have a question, whatever. It can be a 30-second question, or you can get help for 30 minutes, and I'm just available to you all day long. So let me know what you need. All right, jumping into 9-3. This is reviewing, okay? So pause the video real quick, write in your notes 9-3, multiplying and dividing monomials. And then we're going to talk about a little bit of language here that you should be familiar with, but just to make sure, product and quotient, okay? When it says to find the product, okay, that means multiplication, okay, multiplication or multiply, okay? When it says find the quotient, quotient means divide. Now, obviously, we know that ways to show product, okay, ways to show multiplication is just the dot, right? So if you have 4 times 4, we know that's multiplication. You can also write it 4 and 4 with parentheses, because anytime you have touching parentheses, that means multiplication. And looking at the work here, I think those are the only 2 ways we're going to see it. Now with divide, there's 2 different ways you can see it. The first is just obviously the division sign, which that's pretty straightforward, right? 4 divided by 2. The other way is in a fraction. So a fraction is the same as division, and it's like this, and that means 4 divided by 2. So both of those, 4 divided by 2 and 4 divided by 2, they both mean the exact same thing. They're just written in different forms. And then the last thing I want to call your attention to here is the directions where it says express using exponents. So you should be good at this already. We've done this all week. Express your answer using exponents, which means we're not going to actually, when we, like say if we get the total is, or the answer is 9 to the 4th power, we're not going to put in our calculator 9 to the 4th power and then put what that equals. We're just going to leave it as 9 to the 4th power. We're going to express it using exponents. Okay, so that is just a little bit of terminology. Now we're going to get into this new content because we've not done this before. Now, we do already know the terminology, and I'll just review it here. This is called the base, right? And this is the exponent. And I'm going to use those terms through this entire lesson, okay? When you are multiplying monomials, and remember yesterday we talked about what a monomial is. It's a fancy term for a single term. So 4 squared, that I just put base and exponent on, 4 squared is a monomial, times, because there's the dot, another monomial, which is 4 cubed, or 4 to the 3rd power. Okay, so when we are multiplying monomials that have like bases, so again, let's remember here, right, our base, if the base is the same, and I said this a lot the other day, right, if your base is your base, keep it your base. Now, they want us to multiply this, and we've already been dealing with writing multiplication. So I'm going to do this once in long form, and then I'm going to show you the much simpler way to do it that will take about 2 seconds per problem, okay? So the long form of this, or what this question is asking, is 4 squared, which we already know. We've broke these out in past assignments. 4 squared, that's what 4 squared looks like. Let me do this in color here, since I'm not kind of in classroom to point and talk to you. I'm going to do this first one in purple. So this one right here. So 4 squared is 4 times 4. Okay, we know that. We can bust 4 squared out to 4 times 4. Then we're going to deal with the times. So I just put another times. 4 cubed, which just means 4 times 4 times 4. So it's 4 squared times 4 cubed. Okay, and we already know how to write this in exponential form. If you have a bunch of bases that are a 4, we did this on Monday, you just write 4 to the, how many are there? Total, 1, 2, 3, 4, 5. So it's 4 to the 5th power. So the answer here, the product of 4 squared times 4 cubed and expressing it as an exponent, right, is 4 to the 5th. That's our answer. Now, you do not have to bust 4 squared out to 2 4s and then bust 4 cubed out to 3 4s and then count them up. Because look what I did here. With my matching bases, right, 4 and 4, they matched. All I did was added my 2 exponents together. 2 plus 3 equals 5. So when your bases match, like here, 7 and 7, your base is going to stay a 7. Because you're multiplying, that's what this is, because you're multiplying like bases, we know that this means 4 7s, right? 7 times 7 times 7 times 7 times 2 more 7s. Well, if we string all of those in a row, we're going to get 6 7s all in a row. So 7 fourth times 7 to the 2nd is 7 to the 6th. I just simply add 4 plus 2. Okay? On this one, right? Remember I said with parentheses, let's keep our negative in a parentheses, but we have a matching base times a matching base. There's 5 of them here times 3 more of them, which means there's a total of 8, and that's your answer. So hopefully you can see that these are extremely, extremely easy, and that your homework can be done in probably the top portion, which I'm calling the multiply part. The directions are all the same, so we're going to kind of break it off right here. Okay, the top part, it's all multiplication. So it's really just as quick as your base is 9, add 8 plus 6. 8 plus 6 is 14, and that's your answer because they want us to express our answer using exponents. Okay? Your base of 13, add 2 plus 4, you get 6. That one's done. Your base is negative, so I'm going to keep my parentheses, but my base, so I'm going to add 9 plus 5 is 14, and there's my answer. So these really are extremely simple, okay? As long as your bases match, it's very easy. H to the 4 plus 13 is 17. W, I'm not sure why they have those in parentheses, but your answer doesn't need to be in parentheses, but I guess they wanted to use parentheses as opposed to like the big black dot on number 7, which is fine, but no negative, so you don't need to use parentheses. It's just u to the 11 plus 10 is 21. Okay, you can see how quick I'm moving, and I don't ever do these at many examples. You certainly do not need to write all of these examples. I'm usually good as long as you have 3 or 4 examples. You know, you want to use one that has negatives. That'd be a good example to have in your notes. You know, any of the other ones is fine. Just make sure you have a negative and a positive example. But other than that, that is pretty much the gist of the whole, when I say top half, I mean the multiplication part. It's very, very simple, okay? T to the, whoops, lost my pencil. T to the 9 plus 3 is 12. All right, I'm going to jump off of those. I think those are pretty simple. I think you can get the gist of that. If not, jump on the meeting and I can help you, okay? Again, just as a reminder, I broke this one out to explain the why. Right? 4 squared times 4 cubed means 5 cubes all, or 5 4s all in a row. So you write it 5 to the 4th. You do not have to break them out each time. Okay? I just did that once to show you the why behind why you can just add those exponents. Okay. Oops, I drew my line a little early, didn't I? Let's erase that line here. Oops. All right. Drew my line a little early just because I had my screen cut it off and I didn't realize it. So do they get any more difficult? Let's, now that I'm actually scrolled up a little bit, I do want to do a couple more examples in the multiplication side, okay? Not any harder, I promise. Just takes one extra step, okay? Notice these are not the same, right? 4 to the 1st and 8 to the 1st. So I can't just somehow write those with an exponent. But I can just simply multiply 4 times 8, right? This just means, because multiplication order doesn't matter, this just means 4 times 8 times d to the 5th times d to the 6th. Now, you do not have to write it out this way every time. I'm just showing you kind of my thought process, right? So I'm just going to multiply 4 times 8, which is 32. And then I've got matching D, keep your D as a base. And then I have matching D, so I'm just going to add my exponents of 11. So when I say they don't get any harder, I really mean they don't get any harder, okay? 7 times 6 is 42. Now I have J's and J's, so I'm going to keep my J, and I'm going to add 50 plus 50, right? I multiplied my numbers, and then when I multiplied my matching bases, the rule is, because I am certainly not going to write out 50 J's and then another 50 J's, count them up to say we have 100, and then write this. I'm just going to go right to that nice, easy answer, okay? On number 15 here, and again, you don't have to have all 4 of these examples in there, maybe just these 2 because one's a minus and one's a plus, okay? For number 15, again, I'm just going to take 5 times 6, just a simple multiplication problem, just like up here. 4 times 8 was a simple multiplication. Negative 5 times 6 is negative 30, and then just matching B's, keep your B, 9, whoops, I put plus over that, I said multiplication, I think, but just want to make sure that this is right. So I multiplied my numbers, right? It's very simple, negative 5 times 6. And then I multiply b to the 9th times b squared. But I know when I multiply matching bases, all I have to do is add their exponents. Rather than writing out negative 30 and then 9 b's and then 2 more b's, we know that's going to count up to 11 b's. So let's just go straight to my answer. And notice my answer is negative because of this right here. I had a negative 5 times a positive 6, which gave me negative 30. 12 times 12, okay? Now again, these are numbers, but they're matching bases. So this is just like up here, right? They kind of threw it in after some 3 of the more trickier ones. So they want to see if you can go back to matching base, keep your base, add your exponents. 1 plus 2 is 3, okay? So if your bases don't match, like 7 and 6, right? 7 and 6, those bases don't match. One's a 7, one's a 6. We just simply multiply them to get 42. If the bases match, like number 16 here, we just base, keep your base, add your exponent. Okay? All right, so that is the multiplication section. Now let's jump down to the division side. It's not any harder. I am going to break it out once and kind of do it long form to show you why, and then I'm going to show you the nice, simple, quick trick. Just like in multiplication, there was a number 1, I kind of busted out and showed you why, and then the rest of them I showed you kind of the shortcut. I'm going to do the same thing with division, okay? So let's look at number 17 here. All right, so if we take the top, which is there a shorter one? Because that's a lot. Yeah, I'm going to do 15 just because there's not as many to write. All right, 15 to the 3rd divided by 15 squared. Well, let's break this out kind of math-wise first as a division problem, and let's look at what this really means. So I'm going to take this top term, and I'm going to bust it out of exponential form. And what this means is 15 times 15 times 15. Okay, we should be in agreement that 15 to the 3rd really means 15 times 15 times 15. And now I'm going to bust out 15 squared and into expanded form, and that is 15 times 15. Okay, now in math, right, if we have a whole number over a whole number, we know that anything over itself reduces to 1. So I'm going to do it in red here, I can reduce this, right, to a 1 and a 1. I can reduce this to a 1 and a 1. And all that leaves me is this one right here, all by itself, and there's just one of them, so that would be my answer in exponential form. Okay, now that's the long expanded way. And the reason I jumped to that one over this one is because who wants to write out 11 times, all right, and I'm just going to start it. Of course, I'm going to erase it. 6 times 6 times 6 times 6, blah, 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 11 times, right? I don't want to do that. And then underneath, 6 times 6 times 6, and then I'd have all these 6's up here. You don't have to do all that, okay? I expanded it out once to show you the why. Now I'm going to show you the shortcut. Think about what we did over here, right? We had 3 up top, and we had 2 on the bottom. Well, 2 on the bottom are going to cancel out 2 of them, right? So if I had 3 up top and I have 2 on the bottom, I know these 2 are going to cancel out 2 up top. So 3 minus 2 leaves me 1. And it shouldn't be a surprise, right? Multiplication and division are opposites. How did we solve the multiplying ones, right? When we multiply matching bases, we add. Shouldn't be a surprise. When we divide like bases, we subtract. So we subtract the bottom from the top, and that gets us how many we have remaining. So let's go back to this one that I did not want to write out because there were so many 6's, right? If I take 11, right, I'm going to cancel these out, and they're going to cancel out 3 of them on the top. So the 3 on the bottom get canceled out. They also take with them 3 from the top. And so I have how many left? Well, 11 minus 3 is 8. And they really are that simple. Okay? 7's cancel out, taking 7 away from the top. How many do I have left? 2. Okay? 5 of these cancel out, taking 5 from the top, leaving behind 1. Okay? 20 of these cancel out, taking 20 from the top, leaving behind, 10. Okay? These really are that simple. Okay? Now, we know that anything over itself, right? What's anything over itself? No matter what it is, anything over itself cancels out to 1. And if you want to write it with an exponent to really stay true to the example or to the instructions, we can put a 1 as the exponent. Okay? 95 over 95, we've got matching bases, so 18 of these cancel out, take away from the top, leaving none on the bottom. 95 is your base, right? Because that's what our base is here and here, so it's going to stay our base. 21 minus 18 is 3, and that is your answer. Again, you do not have to have all these examples in your notes. I'm just doing several kind of repetition to help. Base is in, keep your base. 11 on bottom cancels out, 11 on top, subtract from that. 19 minus 11 is 8. So when you're multiplying, you add exponents of like bases. When you're dividing, you subtract exponents of like bases. All right, I do want to cover a couple of these, not the story problem, but these, because you do have some like this in on your homework. And it says the product of 5 cubed. So let's write 5 cubed just like that, right? That's 5 cubed because cube means to the 3rd power. The product, what does product mean? Product means multiplication. So I'm going to multiply 5 cubed and 5 to the 4th power. So it's just telling you in words the problems you had up here, and you work them the same. Your base is 5 all the way across, so your base stays 5. It is a multiplication problem. In multiplying, we add those exponents because it's 3 5s and 7 5s all totaling, 3 5s and 4 5s all totaling 7 5s. Okay? Number 26 says the quotient. Well, we know the quotient is a division problem, or we're actually going to write it as a fraction. That's how we learned it up top. So the quotient of 18 to the 9th power. So on top, we're going to have 18 to the 9th power, right? The quotient of 18 to the 9th power and 18 squared, which we know means to the 2nd power. Okay? 2 of these are going to cancel out, 2 of these, leaving 18 to the 7th. Okay, again, we've got the product, so it's multiplication. The product of z cubed. Product means multiply. Z cubed right here. And z cubed right here. And base is a z, so I'm going to keep the base. Since it's multiplication, I'm going to add these exponents, so I get 6. And last, we'll do one more quotient. Again, right, you just need to have one product and one quotient example. So the quotient of, so we know it's going to be a fraction again, right? The quotient of, because quotient is division, so something on top, something on bottom, of x to the 5th power, so x to the 5th power, and x cubed, which is to the 3rd power. That's going to cancel out, take away 3, leaving you x squared. And that's it. You're not going to have a story problem on your homework, so we are not going to mess with that. All right, so that is it. That is today's homework. Thankfully, nicely with an e-learning day, very, very easy homework. And if you have any questions, if it's a short question and you don't want to get on the Google meeting, you can certainly email me. If it's a longer question or you want me to just check your homework to see if you have it right, jump on the Google meeting and I will be very happy to help you. You all stay safe. Maybe you can get a chance to go out and play in the snow a little bit. Bundle up. Have a good day, and I will see you when we get back to school.